Hello out there to you. In this problem, we're going to take apart this monopolies function. We're going to find marginal revenue. We're going to find where is revenue maximized, where is profit maximized, and if this was a perfectly competitive market, what's the situation? That's more of a review question down there, but anyway. So it says inverse demand function is this. We know that's an inverse demand function. Anytime you have P equals something, something, something Q, that's inverse. Um, a standard demand function is going to be Q equals something. So we don't have that here, so we don't need to worry about that, but we do need to turn it into that in order to solve for monopoly situation. Here's their long run cost. Let's get marginal cost out of that. It's the partial derivative with respect to Q of that, which is just 12. So we've got marginal cost. Does the firm have market power? Yes, it does. It can pick whatever quantity or whatever price it wants. It'll sell a certain amount of quantity. That's how we know the demand curve is downward sloping. Okay, marginal revenue function. This is the partial derivative with respect to Q of the total revenue function. So it kind of looks like that. You could write it out with derivative nomenclature too. But what we want to do is we want to find total revenue, which is price times quantity. We've already got that price part right there. And then we'll find the marginal revenue function off of that. So total revenue is going to be written like this. So we want to multiply, since this is the whole function, or that's price part, you're just multiplying it by Q. So you multiply a Q times that and a Q times that. Okay, so that turns into 22Q minus 1 over 250 Q squared. Now, marginal revenue is the partial derivative with respect to Q, so then this becomes 22 minus 1 over 125, because that would be 2 over 250, which turns into 125, and it's Q. Okay, now, if you look at this function and compare it to this function, when the demand curve is linear like this, really all you have to do is multiply 2 times that coefficient and you get that. But you should know how to do that. So anyway, that's marginal revenue function right there. At what quantity and price is revenue maximized? So you do need to know that when marginal revenue is positive, it's increasing the total revenue function. When marginal revenue is negative, it's decreasing total revenue, or the total, or you're in the decreasing part of that function. So revenue is maximized when marginal revenue is 0. So all you have to do is set that equal to 0. So we'll do that over here. This is part C. Set that equal to 0. 0 equals 22 minus 1. That's so hard for me to write like that. 125 Q. Send this over there. Did it again. Okay, multiply both sides by 125, and you get whatever, 125 times 22, 2,750. 2,750. Okay, that is the quantity. And then we want to know what the price is at that particular quantity. So we're going to go back to the original demand function and plug in that quantity, and that gives you the price where total revenue is maximized. Okay, so price equals 22 minus 1/250th times 2,750. You can actually put that up there, and it's going to be 1 over 250 times 2,750, which is 11. and 11 minus 22 is 11. So the quantity is 2,750 and the price is 11. Okay. And the price elasticity of demand for that, we actually know that that's 1. It has to be 1 because that's the unit elastic point. But you could use point elasticity formula. Okay, so point elasticity formula to solve for that would just be, it's the price over quantity times whatever the coefficient on P is. So let's rearrange this function over here to give us the regular demand function. So it would be 1/250th Q equals 22 minus P, and then multiply 250 times everything and get Q equals, we already did, I wrote that wrong. I wrote that part wrong. That's not 200. Oh, no, I didn't write that wrong. Okay. Losing it. All right. Anyway, so we're going to multiply everything through by 250. So 22 times 250 is 5,500. Okay, and then minus 250 Q. Okay, so this coefficient here is 250. Okay, so that's the formula for point elasticity. If you want to know a specific price and quantity point, it's whatever the derivative of, oh, that's supposed to be a P, of this coefficient right here in the regular demand function, or the main demand function. So that's going to equal 1. Okay, the profit right there. Okay, we need to go total revenue minus total cost. So our total cost function is right there. We're going to use that. So total revenue is going to be how many units times the price. So we're going to multiply 11 units times the quantity of products that we want to produce, which is 2,750. So it's 30,250. So 30,250. That's our total revenue. Minus our total cost, which is going to be 12 times 2,750, and it's 33,000. So the 33,000. So the difference between those two, it's a negative number. So 30,250 minus 33,000 is negative 2,750. Negative 50. So that's the loss if we produce at that. Okay, profit maximization. So we want to know where does MR equal MC, and we've already done MR, and MR is right here, and then we're going to set that equal to MC. So it's 12 is our marginal cost, and then our marginal revenue, 22 minus 1 over 250, so minus here, Q. Okay, set everything 1/250th. Oh, I wrote that wrong yet again. It's 125. It's because I'm thinking in not fractions, but I'm trying to write it consistently. Q. Okay, so this is 1 over 25Q, and then that is 10. Q equals, it's actually negative 10. So We've got two negative sides, so now it's positive. We're going to multiply 125 by this side, 125 by this side. So it'll be 125 and 0. This is our quantity. To figure out what our profit maximizing price is, we're going to plug that in back up to there. Okay, so that's going to be 22 minus 1250 over 250, which is, I don't really know. I think it's like 5/4 or something. 1250. It's 5, just 5, and then 5 minus 22 is 17. So 17 is the profit maximizing price. The quantity there is 1,250. So price elasticity of demand is going to be the, we're going to use this formula here. So we're multiplying it by, we're going to get, this is a negative, I suppose. Okay, so price over quantity, so 17 over 1250 times negative 250. And what do we get there? We get, make sure I'm doing that right. I'm going to multiply that by 250, and we get positive 3.4. Well, I mean, it's, okay. It is negative 3.4 if you are using, but if you're using absolutes, it's 3.4. So that's often how it's going to be said, 3.4 in absolute terms. 3.4 or negative 3.4 if you're not using absolute terms. Okay, profit. We want to know the total revenue. So total revenue using profit maximizing price and quantity. It's going to be 17 times 1 times that is 21,250. 21,250. And then our total cost is going to be our quantity times 12. That's 15,000. So now we're making a profit. Difference there would be 6,250. Woohoo, making a profit. That's the most profit we can make because we have profit maximized. 6,250. Okay, deadweight loss here. We have to figure out what the difference is between the perfectly competitive environment and the monopoly situation. So the deadweight loss here, if it's perfectly competitive, is 0. The deadweight loss, though, if there's a monopoly, is whatever the difference is on, why can't I write? I cannot write straight. I don't know where the mouse went. Lost everything here. All right, good enough. 12 is going to be right here. Okay, so it's really just the area of this orange triangle here. Okay, so the quantity of that triangle is where that starts is 1,250 right there. We know this top part is 17. We know that the marginal cost is 12, so that's actually right there. So the only thing we don't know is where this marginal cost hits demand. So we just need to know where does that happen. Marginal cost equals demand. So you can just plug in a 12 into the inverse demand function and then solve for that. I'm going to type it because I seem to be having trouble with writing today. So let's just type that. Okay, so we're just going to plug in 12 Okay, 12 equals 22 minus 1 over 250, and then we're solving for Q. Okay, so we're sending the 22 over to the left-hand side, so that's negative 10 equals negative 1 over 250Q. Multiply both sides by Q. Get some more room here. Multiply both sides by 250. Okay, and this is pretty easy. It's Q equals 250, and then let's tack on a 0 there. So 25,000, 2,500. 2,500 is the end of that triangle, which is this is the quantity if it was perfectly competitive. So it's right here, and it's 2,500. Okay, so this triangle is 1/2 the distance between here and here, which is 5, multiplied by the difference between here and here. So 1,250 is half of 2,500, so it's just 1,250. And I can't do that in my head, so get 1,250 times 5, and then half of that is 3,125. That is the deadweight loss, 3,125. It's the deadweight loss part of that triangle, or the area of that triangle, and we do write those in dollar signs. Okay, so there you go. We've taken apart this problem. You can do similar type things with any sort of demand function or inverse demand function and marginal cost curve.